All right. So I'm the sole hydrologist for Mendocino Road Company, and I have two wonderful aquatic biologists who helped me out with this work, but couldn't make it today, so I'm going to continue on without them. Let's see if I got this right. So what is long-term channel monitoring? It's a program that was started in 1998 when the company was established. It measures the physical habitat of the stream. Our goals are to observe and assess the in-stream changes. It focuses mainly on salmonids, and we usually do resurveys every 5 to 10 years, and we're trying to cover the entire ownership with these surveys. So why are we doing long-term channel monitoring? Various reasons. Basically, we're trying to look at any legacy issues. We're trying to examine the change in forest practices over the many years that we're conducting this monitoring. And we're also looking at impacts due to restoration projects. Other reasons for doing this monitoring is because there's lots of targets out there for in-stream conditions that we're examining to see if we're on target for those metrics. We also have our own internal set of targets on the landscape. So what are we measuring? We're taking longitudinal profiles, cross-sections. We're doing surface substrate samples, and we're measuring in-stream wood. And I'm going to mainly focus on, I'm going to cover all of those, but I'm going to talk a lot about the longitudinal profiles and the pool depths. So how we're measuring it, for the longitudinal profiles and the cross-sections, we're taking a laser level, construction laser level, and a tape measure and just running it across those profiles, the longitudinal profiles and then the cross-sections. Pebble counts, be standard, surface measurements with a ruler, 200 pebbles per cross-section. And in-stream wood, we're just either measuring with a measuring tape or survey staff. Where are we measuring it? All over the ownership, and this map's kind of blurry, but where's the cursor? Oh, there it is. So there's Leggett, there's Mendocino, Fort Bragg. So these are all the stream networks that we're looking at. The red stars are our monitoring segments. So we're in Mendocino County. All fish-bearing segments, predominantly coho segments. The lengths of the stream segments range from about 150 meters up to 750. We're covering 35 planting watersheds, typically very low gradient, 1%. A few segments are up to 7% gradient. And the bankfull widths are on average from 3 to 50 meters. So here's an example of a stream profile that we've done. This is actually on a restoration project in Old Creek, which is in the Navarro River drainage. And this is an anomaly. We don't, this is a dam that was taken out maybe 2 years ago. But I just want to demonstrate that this is what a profile looks like, and then I want to emphasize that here's where we took cross-section measurements, and our cross-sections are typically downstream of the pools at a tail out or in a riffle, and that's it's going to play a key part later on. Here's an example of the pebble count data from those cross-sections. So I just wanted to go over our survey effort. So in red is an original survey, and in blue is a resurvey, and here's what we've done since 1998. So, you know, almost 17 segments in 1998, and then we kind of taped off. That's when I started working there, and then we ramped back up. And then just a distribution of the bankfull widths of the segments that we survey. So predominantly, we're in the 30, 40 foot bankfull width range. Not very big streams, but a few larger ones. And then here's just a distribution of the drainage areas. So typically, not very huge, again, relatively small watershed sizes. And then here's the flow regime that we're looking at, and these are peak discharges in the Navarro, and I'm going to, for this study, or for this presentation, I'm going to break things down based on pre- and post-2006 event changes. So we had roughly pretty close to a 30-year event in the Navarro in 2006. Here's an overlay of our longitudinal profile for a segment in the Navarro. We typically don't sample every single year in each segment. We resample every 5 to 10 years, but this is kind of a focus area where we do a lot of fish studies. So we're out there every year measuring profiles and cross sections. So we take this profile data and we plug it into this wonderful program that's been around for a long time, developed by the USGS. Dr. Mayday's here, thank you. I actually have to kick my computer into XP mode to get this thing to work, so, but it works. And this is an output of it. It gives us residual pool depths and gives us a pool count, and then I give it a trigger to where I say count the pools that are a half a foot or less, so 0.6 meters or less, or I think the other cutoff is 1.2 meters deep. And then here's some pool frequency data. So in blue are the 0.15 meter pools, and in red are the deeper pools, 0.6 meter deep pools. And we see, with bankfull width, we see a decreasing trend there in the smaller pools, but there really wasn't much of a relationship with the larger pools for pool density. And then looking more into, now we do that LONGPRO software does a mean depth per reach. So when we do some kind of trend analysis, we're looking at this changing over time. But for here, we're just looking at, what's that reach mean depth for the drainage area, and this relationship makes sense. Larger drainage areas tend to have larger pools. And then just a little distribution of our mean pool depths. Not a normal distribution, and our range from the time period that we sampled is roughly about ½ meter deep is the average mean depth per segment. Now we can look at trends just in one watershed, not across the entire property. I wanted to highlight some things that we're seeing on the landscape. These are ordered by drainage area. So this is the most downstream segment, and this is the most upstream segment. And what we're seeing here is things tend to be bouncing around here at kind of a stable value for mean pool depth over the years. There's a lot of geology in these there's a lot of bedrock geology in these two segments, so that could be dictating things there. All of these segments have received some kind of treatment for in-stream wood, and this is the only one that hasn't, but it is also the only segment that has an increasing trend in mean pool depth. So lots of different things going on here, but we want to look at the entire watershed. So I took all the segments that had more than 2 resurveys, and I wanted to look at the trend of mean pool depth over the time period that we surveyed, and I had to throw out some that didn't have a significant trend, and I got a sample of these segments. So that this is a positive coefficient, so mean pool depth is trending upward here, and this is just the correlation coefficient, so stronger relationship, positive trend, weaker relationship, lower trend. And so stronger positive trends, but things are kind of split in terms of which direction the mean pool depth is going. So looking at pre and post 2006, again, there's kind of a similar split. We have a lot of segments where things are trending negatively, and then we have a few more, a little bit more than the negative number that's trending upwards. So we had about 30 segments that we could get a trend on. And this is just a summary of that, and I applied this Wilcoxon rank sign test to those 29 segments, and there wasn't a significant relationship for that test. So, but again, 17 of the segments were trending upwards in terms of mean pool depth, and 12 were trending downwards. So then I went to see, is there something going on in terms of are smaller watersheds exhibiting a difference, larger watersheds trending a different way? And so I looked at the smaller watersheds, and it looked like, yeah, there's a predominance of mean pool depth increasing. So we had 10 segments where things were increasing and 4 where they were decreasing. But again, applying that rank sign test, it wasn't a significant level. I looked at the larger drainages, and it's kind of split 50-50. So, but again, that trend, that relationship wasn't significant either. And this is a pool frequency over time for the all of the segments sampled. Again, it's just kind of bouncing around, but that could just be an artifact of the segments that we're sampling in any given year, because we're not covering the whole set every single year. Same thing for the large pools. Things just seem to be bouncing around, no major positive or negative trend. Okay, on to cross-section data. Again, these are typically at a tail out of a pool or in a fairly uniform ripple. And there's the laser level, you can see it there. We install rebar pins on either bank, and here's again a same section in the Navarro River, just looking at those trends in the cross section. So I looked at, for these, I think I have 10 segments there where we have pre and post 2006 data. Looks like there is a predominance of this is a negative slope of that trend line, so the pools are filling in, and these pools are deepening. I wouldn't call them pools, just cross sections, I should say. So looks like the cross sections are filling in according to that data. And again, just summarizing it, 7 segments had them filling in, 3 were getting deeper. And I looked at drainage area, is there something going on with drainage area, and there was definitely more activity going on in the larger watersheds, which seems to make sense too. If we have a lot more hydrology going on, that there are going to be more changes. Was there a relationship in those same segments of the change in the mean pool depth and the slope of the trend line of the cross-sectional area? And it kind of fits with the idea that our cross-sections are, again, at the tail-ups of the pools, and so if we're getting a deepening of the pool, it should be depositing just downstream in those cross-sections. So it tends to fit with the idea that if the cross-sections are filling up and the pools are deepening, we're seeing that relationship showing up. So on to the pebble counts, everybody's favorite part of this work. We used to only do about 50, way back in the day, we only did about 50 pebble counts per cross-section, and then we upped it to 100, and then one of our aquatic biologists went up to Humboldt Reva Company to work with them for a while, and he said we needed to do at least 200, so we blamed all the tedious work on him. So here's the substrate conditions pre and post 2006, and we're seeing a fining of the substrate based on all the data. So that kind of fits with the idea if the cross sections are filling up, they're depositional areas, there should be some fining of the surface. And again, 16 were a decreasing trend, so a fining trend. in the surface substrate. Red is the D50, blue is the D84, and only 6 of the segments had a coarsening of the substrate. So on to in-stream wood. This is an example of just a project where we actually artificially placed in-stream wood and made a pool. But we measure all of the wood in the stream, not just in-stream enhancement projects. So here's the metrics that we collect when we look at in-stream wood. We look at the species, the dimensions, if it's associated with each other, how old is the wood, does it have any special characteristics, its location, and what the input processes were. But for now, I'm just going to focus on the dimensions and what the wood is doing in the stream. So here's kind of the trend over time. Again, we're not resampling all of the segments every year, so this could just be an artifact of where we're sampling in that year, but we are seeing kind of decreasing trends across the board in volume, but that's to be determined about if we are in any given segment what the conditions are. So here I looked at changes pre and post 2006. Again, looking just at volume, and where we're at, this is where we added wood artificially, and so I just wanted to make sure that we were capturing the wood data, and yes, after, actually this isn't pre and post 2006, this is pre and post wood projects, so adding wood artificially to streams. And so yes, we did see an increasing trend in wood, makes sense. We added wood to the stream. And then here's the resulting pool depth changes pre and post wood enhancement, and we are seeing the mean pool depth increasing for those segments. So adding wood does make deeper pools, that's the whole idea. So the grand conclusions are that the pool depths appear to be increasing, but the trends aren't significant. Pool frequency seems to be stable. Cross-sectional areas are decreasing, and this supports the assumption that if the pool depths are increasing, the depositions occurring in those cross-sectional areas, and the substrate is fining, and again, that's at the same cross-sections. And wood enhancement projects are making deeper pools. So that's pretty much it. We have time for at least one question, possibly two. Yes, sir.
It's really just a procedural question. What do you do? You said your cross sections are the tails of pools. What do you do if the pool moves?
Yeah, well, we initially established the cross section a tail out, and if the pool moves, we typically just keep sampling at that spot. And I haven't had time to sort through the data to delineate or denote which ones are actually still a ripple. But yeah, we'll have in-stream projects where we'll drop trees right through the cross sections, and the survey crews get really mad because that's, we had a nice straight uniform ripple or tail out, and now we just messed up their survey. So
one more question. No? Thank you.